What do fuel, perfume, plastics, and even vinegar have in common? They all come from the fascinating world of organic chemistry. Today, in just 5 minutes, we will break down the essential building blocks from alkanes to ester with clear structure, key point, and real life example. So let's dive into the chemistry that power our world. So first, what is organic chemistry? Organic chemistry is the branch of chemistry that studies carbon containing compounds, especially those with carbon hydrogen bonds. It is the chemistry of life, covering fuel, medicine, plastics, and much more. So let's explore the organic compound that form the foundation of organic chemistry. First, alkane. Alkanes are the saturated hydrocarbons. They have general formula CnH2n plus 2. Alkanes have only the single bond between the carbon atoms. Here we have an example of methane. In the methane molecule, carbon is bonded with the 4 hydrogen atom by a single covalent bond. So due to the saturation and single bond, alkanes are relatively unreactive and are used as a fuel. Next is the alkene. Alkenes are the unsaturated hydrocarbons. They have general formula CnH2n. Alkenes contain at least one double bond between the carbon atoms. Examples of alkene is the ethene molecule. And in the structure of ethene molecule, we can see that the carbon atoms are bonded with the other carbon atom by double bond. And in the double bond, one bond is sigma and the other is pi bond. As the pi bond is weaker, so the alkenes are reactive and used in making plastics. Next is the alkyne. Alkynes are the hydrocarbons that contain one triple bond. They have general formula CnH2n-2. So the alkynes contain at least one triple bond between the carbon atom. Here the examples of alkyne is acetylene or ethine C2H2, and here in this molecule the triple bond is present between the two carbon atoms. Alkynes are used in welding and organic synthesis. Next is the haloalkane. These are also called the alkyl halides. Haloalkanes are formed by the replacement of one hydrogen atom in an alkane. We have an example of haloalkane is the chloromethane, that is CH3Cl, and it is formed by the replacement of one hydrogen atom from the methane, that having the formula CH4, and after removing the one hydrogen atom it is replaced by the halogens, that is the chlorine, and this is called alkyl halides. Haloalkanes are used in refrigerants and solvents. Next is the alcohol. Alcohols are the organic compound having OH group. They contain a hydroxyl group, that is OH. The general formula of alcohol is ROH. Examples of alcohol is ethanol, that is CH3CH2OH, and in this alcohol molecules a specific group which distinguish. Alcohol is used in beverage and sanitizers and fuels. Next is the aldehyde. Aldehyde having CHO group at the end of the chain in organic compound. It contains formyl group, that is CHO, at the end of the carbon chain. Examples of aldehyde is the formaldehyde, that is HCHO, and it is used as a preservatives. Next is the ketone. Ketone having the CO group, and CO group is present in the middle of the chain. It contains the CO group, that is the carbonyl group bonded to the 2 carbon atom. Examples are propanone, that is CH3CO and CH3, and ketone is used as a solvent and in nail polish removers. Next is the carboxylic acids, that is the functional group is COOH. Carboxylic acid contains the carboxyl group COOH. Example are the acetic acid, and it is found in vinegar and is used in food preservations. Next is the ether. Ether are the linkage of ROR. It contains one oxygen atom between the 2 alkyl group. Examples are the diethyl ether, which contain 2 ethyl group on the either side of the oxygen atom, and it is used in anesthetic and solvent. Last is the ester. Ester contain the functional group COOR, and it is formed by the reaction of carboxylic acid and alcohol. Examples of ester is ethyl acetate, that is CH3COO CH2CH3. Esters have sweet smelling compound used in perfumes and flavors, and its structure is unique from all the organic compound because in its structure there is 2 oxygen atom which is bonded by the carbon and alkyl group. If you found this video helpful, please like, subscribe and share with your friends and fellows. Thanks for watching.